Hello, everyone, and welcome to today's webinar titled Advancing HSC Research, Discover Miltenyi Biotec's Comprehensive Portfolio of HSC Separation, Expansion, Transduction, and Analysis Solutions. I am Gabriela Goldberg. I'm a product manager in Miltenyi Biotec, and I'll be your moderator for today's event. So today's educational web seminar is presented by LabRoots and brought to you by Miltenyi Biotec. To learn more, visit www.miltenyibiotec.com. We encourage you to participate today by submitting any questions you may have during the presentation. To do so, simply type them into the Ask a Question box to the right and click Submit. We'll answer as many questions as we have time for at the end of the presentation. You may also use the Ask a Question box to let us know if you are having any trouble seeing or hearing the presentation. I'd like to now welcome our speaker for today's webinar. Richard Yao is a technical sales consultant for Miltenyi Biotec, and he is based out of the Ontario region of Canada. For a complete biography of our speaker, please visit the Biography tab on the top of your screen. Welcome, Richard. Now you may begin your presentation.
Thank you very much for the introduction, Gabby. Hello, everyone. Welcome to today's LabRoots section. And my name is Richard. I'm the technical sales consultant at Miltenyi Biotec that covers Ontario territory in Canada. And today, I hope to have a quick introduction about our portfolio and research tools for hematopoietic stem cell researches. Just a quick disclaimer that so for today's introduction on all the reagent and the tools we have will be specified for research use only. We do have a portfolio for clinical application, but it won't be mentioned or introduced by today's section. So stem cell, we have multiple levels of them. We have the zygote, which basically have the totipotency over here. It would be having the capacity to develop into all kinds of cells. And we have the pluripotent stem cells, which in fact the iPSC, the induced pluripotent stem cell, is a very popular research area nowadays as well. But today we hope to focus a little bit on the level down of it, which is a multipotent stem cell, and specifically the hematopoietic stem cell, which is actually a very unique and a very popular research topic nowadays due to its importance and potentials among both regenerative medicine as well as immunology study, as well as the transplant of the therapeutic applications as well. So let's begin that. So hematopoietic stem cells, as the name shows itself, it is hema, so we get that from the blood. There are multiple tissue samples or biopsy samples available from human patients or donors that we can get this kind of stem cells, and they are majorly all associated to the blood samples. So again, this is stem cell we are talking about, so the abundance rate is quite low over here. Bone marrow and cord blood generally have a higher percentage of that, but even with that, we're talking about something less than 2% in most of the cases, but in extreme cases, still less than 3% in terms of its abundance rate. And in some cases, if we are talking about getting this from regular adult human patients or donors, the kind of samples we can get is typically a buffy-coat, or even in most of the case, just a regular peripheral blood, in which cases, as you can see from the slide, the percentage we have on the stem cell is actually fairly low. We are talking about less than 0.1% over here. Of course, there are methods to get more of that, which we typically call that the apheresis, in which case we simply are treating the donor or the patient with typically a growth factor, in which case those growth factor will be able to mobilize the stem cell from the bone marrow into the circulating system. And after that, we can collect those cells through the processing and collection, and those buffy coats or leukoplaques from it will typically have a much higher percentage of the stem cells. Sometimes they can rise to more than 2% over here. And that kind of sample It's typically called a leukopak, where most of the red blood cell and platelet has been removed from the sample, and you are basically having a much higher percentage of mononuclear cells to start with, and potentially a much higher percentage of hematopoietic stem cells. So regarding, no matter what is a blood sample you are talking about over here, unless you are working with a clinical, there might be certain difficulty for you to get this kind of a blood sample and resources to get enough cells for you to do hematopoietic stem cell researches. In that case, Miltenyi actually have a whole portfolio of blood products available for you. So no matter if it is a buffy coat, a whole blood from all kinds of donors, different kinds, or even a leukopak or a mobilized leukopak, we actually have that resources available as well. So if you are not working in a clinical and you are having issue having the blood sample for your HSC researches, please feel free to check out further on our quality blood products portfolio, and we might be able to have the tools for you. So now we got the blood samples ready, and we are officially ready to start our hematopoietic stem cell researches. And by doing that, I hope to today go through that by a typical workflow over here. And as you can see, the whole workflow involves a few steps. At the first, the step is actually going to get the hematopoietic stem cells from whatever blood samples you are having. And then we're talking about the further hematopoietic stem cell isolation by getting those purified samples. And then we are further talking about HSC contouring by expanding them through the cell contouring system, and then a flow cytometry analysis of HSC's portfolio. And the last but not least, humanized mice model that basically is a mimic of the human immune system transplant system applying hematopoietic stem cells. So the first step is actually collecting the mononuclear cells from the blood sample we have over here. So you are either getting a leukopak, a buffy coat, or even a whole blood, and that involves, once again, very small percentage of hematopoietic stem cells, and the majority of them is actually not what you need. So the first step, actually the most important step, is actually how to purify the sample and get rid of the most of those cells that you don't really need for your HSC studies. And to do that, a very typical or the standard way to do is actually this over here. If you do play around with a lot of blood samples, you likely know what this is the second you see this image. So this is actually a FICO density gradient cell separation by running the FICO buffer. The idea is quite simple over here. You are laying the FICO density gradient solution into a fax tube or Falcon tube like this. And then you are very carefully overlay the blood that has been diluted in with a PBS buffer onto the top layer of the FICO buffer. And typically we will run a room temperature at least 30 minutes long centrifuge. And after that, you took out the tube very carefully and they will look exactly like this. And the separation is basically was due to the density gradient separation over here. So the bottom part, the red one, would be actually most of the red blood cells. The pink one layer would involve most of those granulocytes, which is majorly neutrophils from it. And then top is a plasma, and the interface over here, the cloudy part, the kind of white buffy coat region, that is where you have most of your mononuclear cells, and that is where the hematopoietic stem cells hopefully will be locating at. So this is kind of like the standard procedures that people have been done to processing blood sample for many years. And a lot of the time, people don't really know there might be alternative options to change this protocol. They just get used to it. And because of that, they rarely consider about the potential darn shortage of this protocol, which actually, if we check the FICO's datasheet, which is provided by Cytiva, who owns the FICO brand, on section 12 over here, they actually mention to you what is a downstream major shortage over here. So yes, you are getting a decent amount of mononuclear cells among that, but you are going to lose potentially up to 40% of the lymphocytes from the collections over here. But what really is not the really ideal for hematopoietic stem cell research is actually, as you can see over here, you are going to get about roughly up to 5% of the granulocytes, which the majority part is actually neutrophils. And if you are doing this kind of study, you know how sensitive a neutrophil is and how easy it is to activate them. And they are not good to keep the healthy situation of the hematopoietic stem cells. So in order to overcome that, we actually have a very interesting protocol that is based on not density gradient separation, but a magnetic-based separation over here. The idea is very simple. We are simply adding the RBC antibody quickly to the blood, and within 5 minutes, we are going to cause most of the RBC to sediment. And then we took out the top part quickly. We quickly spin them down, and then we add in the microbeads system that will be recognizing the remaining RBC and the granulocytes. And then we run through a magnetic-based separation system to removing all those granulocytes and remaining RBC. And this system, when we are checking by flow, is actually showing a significantly better situation in terms of the contamination by neutrophil or granulocytes over here. As you can see that compared to the traditional density gradient separation, 7%, our system has a less than 0.1% abundance rate of neutrophil. So you are going to have a hematopoietic stem cell extraction ready system with a solution that potentially will have much less contamination of neutrophils and potentially much less activation caused by them as well. So the idea of the magnetic-based separation is actually pretty simple. We all know that a different cell has different surface markers, and because of that, you can use antibody to recognizing specific cell markers, and by doing that, specify and mark specific cell populations. So we add in the antibody that can recognizing the interesting cell that has a specific markers. The antibody is then conjugated to the magnetic microbeads over there. We incubate them and we load the whole cell solution into a column that has been fulfilled with steel sphere matrix structure that is attached to a strong magnet. By going through these magnetic columns over here, all the cells that has not been attached to antibody, which does not have the nano-sized microbeads, will drop out and you can easily collect all of them. That is your negative portions. And after that, you can simply take out the columns, adding the elution buffer and punch them through. And since they no longer are attached to the magnets, those cells that has been recognized by the antibody with the magnetic microbeads will then be plunged out and flushed through to another collection tube, and that is your positive portion. So this is a very simple but efficient way to do a quick cell separation based on their surface markers. You might actually heard of this kind of magnetic separation. You might have not exactly used our column-based portfolio, which is showing on the left. What you might having, it might be some other vendors magnetic-based separation that is a column-free system, which typically looks like what is showing on the right of the image. You basically have a special kind of magnets that has a well in the middle, a hole, and you can basically insert in typically a 5 ml fax tube, 12 mm times 75 mm fax tube with a cell and antibody and microbeads within it, inserted in, incubate that, and then pull the solution out to get the untouched cell. So both systems are based on the same kind of familiar idea of magnetic one and with the antibody. But you might be wondering, what is the difference over here? Well, the major difference, I would say, comes towards the efficiency, and that specifically is due to the distance. So what I mean by that? Well, let's showing that by another example that you might think is not totally related. So in a solar system, all right, we actually have a fundamental unit called the astronomic unit, AU, which one AU actually representing the distance between Earth to the sun. We use that to measuring how much further different planet is having towards the distance with the sun. And as you can see over here in our solar system, the furthest one is actually Pluto, which I guess sadly is no longer a planet from the recent definition. But over here, I still want to use that as an example because as you can see from the image, it's pretty far from the sun. It's about 40 AU, so it's 40 times further in the sun compared to the Earth. But there are something further than that, relatively speaking, and that is the distance between the cell to the magnetic resources in a column-free system compared to a column-based system. And here is an image to show exactly what that means over here. So on the left, this is typically how a column looks like from our column-based system. And on the right, that is simply your fax tube, the one that is used by a column-free system. And if we go further within it, you can see that this is actually the Steele-Saphir matrix we are talking about over here. And because, again, this is a metal small Saphir, they can efficiently expand the magnetic force, the magnetic field that is attached by the magnets towards the column. And because of that, you do not have the reduction of the magnetic field as you go through the column. And the cell, when they go through the column, they're drifting through the gap between those Saphir, which to the maximum is only a distance of about 10 to 20 size of the cell diameter. So it's at probably 100 micrometer range. On the other hand, what you have on the right is actually the fax tube, and the diameter of the fax tube is actually 6 mm, so that is 6,000 micrometers. As a result of that, sometimes we would say the distance between the actual magnetic resources towards the cell in a column system is potentially 100 times shorter compared to a fax tube-based column-free system. And if you check out the relationship between the magnetic forces towards the distance over here, it actually is in relationship to the powers of 2. So that means 100 times shorter distance is 10,000 times stronger in terms of the selection forces. And because of that, by applying the same amount of antibody and microbeads and the concentration and all that, the selective power from a column-based system will simply be much stronger compared to a column-free system. And in order to overcome that shortage, the vendors that is providing the column-free system will generally require a higher concentration of antibodies, or their microbeads that is used to produce this selection force, will generally speaking to be much bigger. And last but not least, some of the vendors, in order to increase the bonding efficiency to make more antibody attached to the cell, they will have the incubation temperature to be at the room temperature instead of 40 degrees, which further upon is going to potentially activate the cell population. And that might not be ideal for you, especially for stem cell researches, which is what we are talking about here today. So for rather cell population like a stem cell researches, this is kind of quite important. And I hope if you are doing a magnetic separation to keep this in mind, because a cell's health is actually quite important for you. And that because of that, that is why our column-based system is actually approved by FDA to apply on clinical applications where we can literally use this technology to do cell separation ready for something clinical, such as genome therapy, as well as regenerative medicine. Whereas in a column-free based kind of system, it is really difficult to achieve that level due to the safety issue or non-specific cell activation. So with that, I have introduced to you about how the column system for magnetic separation works and what is the advantage for that. And now we are ready to introducing specifically what we have by using this kind of column system to do a hematopoietic stem cell separation from the upstream samples that you have, typically a PBMC sample. There are multiple markers for that to labeling the hematopoietic stem cell. But the most abundant or the typically most popular one to use nowadays is actually CD34 that we are marking them. And downstream, after getting the hematopoietic stem cell, we also use some lineage cell depletion kits that is labeling everything but the CD34 HSC to removing those things and get the untouched HSC, and in this way keep the pluripotency of the HSC. So that's why we have this most popular microbeads kit called the CD34 microbeads, the ultra pure version. So this beads is using the magnetic cell separation principle that I have just introduced, and it will be able to efficiently recognizing the surface marker CD34 and do HSC separation based on that. And the result over here showed by flow cytometry showed you how efficient it is. The top is before separation, the bottom is simply after the separation. You basically get most of the CD34 out from it. And you might notice that the name has ultra pure over here. So we also have the CD34 microbead that's not ultra pure, that is standard. And what is basically the difference over here? Well, here is comparison data for that. So the amount of the CD34, which of course is the parent gate, if we compare that, you can see the result is more or less similar. But what is actually the actual advantage towards ultra pure? It's a step before that. That is when you are comparing the total amount of cell events, the percentage of ultra pure's CD34 is actually much higher. What exactly does that mean? Well, once I show you the flow data, it will make much more sense over here. So basically what it looks like is that if you see over here on top is a regular CD34 microbeads. You have the typical gating typically over here for mononuclear cells. And then you are getting out based on CD34 positive over here. You can see over there for that both to the standard and ultra pure version can efficiently recognize in towards a CD34 positive HSC. But simply, if you are having a sample that has a lot of debris, which could be referred towards the left debris dirty chunk that was not being gated from the first gate, you can see that compared to ultra pure beads, a standard bead that doesn't have as powerful efficiency to actually get rid of those debris. So the advantage for ultra pure sample is simply it will be able to very efficiently reduce the carryover of debris and dead cells from the positive fraction. So if your sample is, relatively aged cord blood or peripheral blood, whole blood, this could be something ideally to consider because you likely will have quite some dirty chunks of debris over here, and this kit can help you efficiently removing that. We also have data compared this to some major marketing vendors over here that is kind of our competitors. And as you can see over here, that is similar towards our regular beads, the vendors beads does not have efficient kind of ways to get rid of those debris, if anything better. By the way, this is also a column-free system. And you can see over here that compared to either the standard beads or our competitors, our ultra pure version simply have a much better efficiency in order to removing those dirty debris. So again, if you are doing aged samples, this is definitely a better thing to consider about. And further upon the last one I hope to show you here is a similar data from a cord blood, which is quite unique over here, because if you are getting cord blood, chances are you are likely not getting a fresh one. You probably are getting like an aged frozen one, and therefore you might have quite some debris chunks over here. And again, our ultra pure version can help you efficiently get rid of it. So with that, I finished our introduction about our CD34 magnetic beads that can help you very efficiently get the HSCs. And downstream, what you might actually really need is actually some cell culture media, because a lot of HSC group, after they're getting a hematopoietic stem cell, the next thing they want to do is actually doing some expansion towards it. And with that, I would like to introduce you our cell culture and stimulation portfolio specified for human hematopoietic stem cells. So first of all, we have all those premium grade cytokines that you need from that is necessary towards the HSC expansion. Over here, we not only have that, we also have our HSC expansion basal media that is designed in a serum and xeno-free system. So you are having a very clean cell culturing environment, and that can work together with our HSC expansion cocktails and they designed together can give you a very unique and uncomparable efficiency in terms of the HSC expansion speed. We actually compared our special unique setting up when we compare that to all the major vendors in the markets over here. And here is our efficiency compared to all of them over here. So there are quite a few different competitors we have selected over here for that. And we simply are controlling them under the same situation after 7 days of expansion, and we examine the percentage of CD34 positive cells to evaluate their efficiency. And you can see that we are basically outperforming every single one of them. So if you are doing hematopoietic stem cell research and expansion is something you are maintaining on a daily basis in your lab, I would highly recommend you to get in touch with us so we can arrange to send you a bottle of this expansion media to give a try. And you can do a side-by-side comparison of using this media with whatever you are using right now. And we are pretty confident this is likely going to increase your yield significantly. So a number of CD34 positive hematopoietic stem cell is not the only thing over here. Another very important thing that people cares a lot in terms of HSC is actually its potential on differentiation. And we examine that as well. So basically, we examine that by running the typical clone forming unit assay, which I will introduce in further downstream. But basically over here, what I hope to quickly show you is that we, again, examine our expansion media settings, compare that with all the other major vendors in the market when we're doing a comparison on the clone forming unit from different CFU. And you can see over here that our media's growth HSC, if it will perform either equivalent or actually better in terms of its diversity of the CFU compared to most of the vendors over here, showing that is not only having the highest amount of HSC expansion efficiency, but also have a very decent CFU diversity, which proved to have a great potential on differentiation as well. So with that, it's time for us to go through deeper to review about the CFU assay, which is a clone forming unit assays over here. So this assay, you might know, it's a very typical assay over here. People tend to use this one to differentiate the HSC from a single cell to a cluster, and they form different kind of cluster that will have different morphology under the microscope. And each specific kind of morphology of the CFU is showing a specific cluster that showed a specific downstream development potential towards a specific cell population. Either it's a granulocytes, macrophage monocytes, RBCs, or the other cell type over here. Again, as it develops, goes on through the portfolio showing over here, it start to lose its differentiation potential and start to literally develop to the actual functional cell type. So this is how we examine the differentiation capacity of HSC. And for that, we have our HSC CFU media that I would like to show you, which is basically a very standardized semi-solid media that we simply can use to contour the single cell HSC and let them develop into the CFU unit. It's a very standard application that we have. And we also compare that to the relative competitors in the market that also has a HSC CFU medias. And as you can see over here that in both cases, either it's a cold blood sample or bone marrow samples, our CFU HSC assay media actually will perform slightly better compared to the competitor. So if you are doing the CFU and you are considering about getting a media to increase its differentiation potential, I would highly recommend you to give a try on this one as well. So after you got the CFU assay set up, very interesting thing I want to talk to you further is about how to examine them. So like I mentioned previously, the very old school or standard way to do that is examine the morphology of the cluster under the microscope, right? But it's not necessarily to be the only case. And with that, I would like to introduce you this special thing we have under the flow cytometry portfolio that we can use for CFU examination. So again, CFU, the HSC CFU assays, traditional way, you get them into these 6-well plates. You wait for a few days until they grow into the clusters. You see them under the microscope. You see how they look like, and then you kind of subjectively determine what kind of cluster it is, what kind of CFU it is. But it's a very slow process. It's involving a lot of human subjective determination. And also there are chances of error. It's taking a long time, and it does not have to be the only case. What we have over here is that we can run the same assay, but in an automatic high throughput manner that we can run under the 96 well plates, and then we can examine the result by using flow cytometry. And the result, therefore, will be user independent, and it will removing most of the subjective factors. It will be a very objective kind of a measurement. The result tend to be hopefully much more accurate as well. Why we can do that? Well, here's the thing. So we have a few markers that we can use to specifically determine what kind of CFU it is, because different CFU will have a different expression pattern among CD14, CD15, and CD235. So the BFUE, they will have a 50% of them express CD235 positive. CFUG will have a 50% expressing CD15 positive, and so on and so on. Basically, every single CFU, we will be able to have a special ID code based on their flow cytometry pattern of those 3 surface markers. And by doing that, we would be able to determine by using a flow cytometer what CFU it is, instead of measuring that manually by using a microscope. The idea is pretty simple. So on day 0, again, you are seeding those CD34 HSC in 96 single well with hopefully single cell in each single well. You proliferate them by using the HSC assay media that I have introduced for about 2 weeks. Let them grow into this kind of CFU clusters, and then you run through every single well through the flow cytometry. And then what you get is actually a flow result based on this. And for each single wells, the flows expression on surface marker CD15, 14, and 235 will simply hopefully give you a strong measurement on what kind of cluster it is. So by doing that, you would be able to automatically read out every single well for your measurement. How accurate it is? Well, we have actually done this kind of comparison in our lab, where what we did is simply we use this flow cytometry assay, and we use exact same sample and used a very experienced scientist that we have in our R&D team to do our old school microscope kind of measurement. And once again, this scientist is very experienced. She has done this for a long time. So her measurement is hopefully to be very accurate. And we did this kind of blind test and compare the result over here. And as you can see from the bar chart, our flow cytometry readout is very similar towards a very experienced researcher's readout in terms of the CFU clusters, which is hopefully showing that this machine indeed is very accurate and very precise in terms of predicting what is a CFU by using a flow cytometry experiment. So again, this is like a user-independent, clear, and automation way to do this in a high throughput manners. So especially if your lab does not have a very experienced technician that could be able to efficiently determine the CFU by using microscope, this will be strongly recommended for you to consider to give a try with. So with that, I actually finished the majority of the sectors of the research tools. And this last section over here is more like a summarize of what we can use by putting up everything I introduced together to do our actual really cool and a very popular application nowadays, which is developing the HIS, which is a humanized immune system in a mouse model. So HIS, it's a very powerful humanized mouse model that has been used a lot because simply you would be able to mimic human immune system in mice which can open towards much more potential towards vivo studies that you don't have to do, that will be much harder to do if you are having is actually a clinical kind of system with real human patients. The idea of that is very simple. You can either injecting the CD34 positive hematopoietic stem cell into an immunodeficiency mouse, and then you will using those stem cells to develop hopefully the whole immune system in the blood of those mouse. Which by doing this is typically a very long kinds of a protocol that will last more than 10 weeks. And also it will have a T cell restriction in terms of the murine MHC, of course. But the advantage for this is that after this kind of long setup, you will establish literally the complete human immune system over here. And because this is like the novel kind of development of the immune system, you don't really need to worry about the GVHD or the graft versus host disease over here. So this kind of mouse is ready for long-term immuno studies. Alternatively, what you can have is simply quickly doing a PBMC injection towards this kind of mouse. And what you can develop is like a quick and relatively dirty kind of mouse model that, because again, this is PBMC, can give you a relatively more efficient T cell engraftment. But again, because this one is an injection of PBMC instead of stem cell, it will have a poor myeloid cell engraftment, and therefore this one couldn't last very long. This is relatively used for a short-term study and more specified towards like a T cell related immuno studies as well. So either one will have a pros and cons, but of course over here, our focus today is actually on the first one, which is using the hematopoietic stem cell in order to develop that. Again, the idea is very simple. You use the CD34 plus cell isolation tools that we introduced in here today for magnetic cell separation. We then do a quick analysis by HSC to make sure that this is a purified HSC that we are having. And then we inject that to the mouse that has been developed immunodeficiency artificially. And then we quickly evaluate the HSC reconstitution within the mouse body to see whether the whole immune system has been developed. And then we are basically finishing and conforming the generation of a HSC mouse over here. Simply just want to go through a little bit more details over here. So the step over here is, again, very simple. The first step is to get the blood samples out from it. So again, you can use our magnetic-based PBMC isolation kits to get efficiently HSC ready PBMC for it. Or alternatively, I think some relatively rare group will use fetal liver to do the same thing, which we won't go through details, but we have this gentle max dissociator that can finish and extract out a very efficient single cell suspension for you to get the cell ready for HIS development from the fetal liver. So if you got more interest on that, you can attend our later webinar about the gentle max dissociator to learn more about it. But either way, you got your cells ready for that. And then you are using the magnetic-based separation that we introduced about to get you a very high purity, high viability, high yield, and high quality CD34 positive hematopoietic stem cells using either an automatic platform that we have or a manual platform that we have. And then you got a very purified CD34 cell population out from it. And then basically you do a quick QC test by flow cytometry, and then you'll be able to quickly examine the differentiation efficiency of the HSC, and then you can inject them to the mouse, and then after that, quickly examine whether the whole immune system has been developed from it. We actually have an 8-color immunopanel design ready, so once you get that one, you can quickly scan the single panel, and that will be ready to screen all the immune cells from this kind of mouse ready for you by checking a flow cytometry. So that is a whole patterns over here that is ready. So basically, I guess a take-home message we have is that for your HIS development, we have this one-stop shop that is ready for all the steps through the whole long procedure for you. And with that, I have finished today's presentation on all the sections that we hope you to talk about. And here are some useful links that you might be interested in to review further if you are developing this kind of HSC studies. And if you got any questions, please feel free to get in touch with me. I guess we are now open for the Q&A sections for today's presentation. Thank you very much.
Thank you so much, Richard, for your informative presentation. So now starts the live Q&A portion of the webinar. If you have a question you'd like to ask, please do so now. Just type your question in the Ask a Question box and click Submit. We'll answer as many of your questions as we have time for. So let's get started. It looks like we already have a couple questions in the Q&A. So the first question is, what source provides the most number of HSCs? And does Miltenyi offer any biospecimens?
Thank you very much. Yeah, that's a great question. So we actually have a handbook for hematopoietic stem cells, and I believe we should be able to send out the information for the link after the presentation today. But basically, we have that handbook introduced for multiple of the blood resources we can provide to researchers in order to get the hematopoietic stem cells with. But in general speaking, if it's for a clinical labs, typically they would collect the regular adults, patient or donors peripheral blood or the whole blood to start with the collection of the hematopoietic stem cells. So the pros for that is, relatively speaking, it's very easy to collect them. And the cons, of course, is that for the adult blood, the percentage of HSCs in it is very low. In general, we are talking about less than 0.1%. On the other hand, if there are labs that is doing HSC and they do have a potential sample banking, what they tend to have is cord blood, which typically speaking would be having a percentage much higher. We are talking about 1 to 2% potentially. So that would be other resources. When it's going to massive scale, there are people in the lab that they would potentially collect the leukopak, which is basically the leukapheresis samples that is filtering out the majority of the red blood cells from it, and it's a massive collection bags of the immunocells or the mononuclear cells from that collection. And from that sample, typically we are talking about the HSC percentage of sometime potentially 1% or even higher than that. And now, last but not least, this is more applicable towards a clinical application. We are talking about the mobilized leukopak. That is where the donors will be injecting with growth factors within it. Those growth factors in the body is going to mobilize the hematopoietic stem cell to be moving out from the bone marrow into the circulating system. And then after that, we do this leukapheresis. And as a result of that, this kind of leukopak will be further having a higher concentration of HSC even compared to regular leukopak. Sometimes we are talking about more than 2% from it. So in brief summarize, Miltenyi, we actually provide blood samples for all those types of samples that we mentioned over here. I mentioned over here for you. So I guess the best way to approach that is actually getting in contact with your local technical sales consultant to have a better discussion with them based on your budget, based on your need, and based on how many HSC you want to start with. We can set up the best way and give you the best suggestion to start with what kind of sample to do your research with. Yeah.
Very good. Okay, so the second question we have here, it says, I noticed Miltenyi has 2 CD34 microbead kits. One is called Ultra Pure. What does that mean, and which one would you recommend?
So the Ultra Pure, as the name shows, it's ultra pure. So the major difference is that it's providing an ultra pure result. So, but what exactly that means, I guess that is more like your question, why we call that ultra pure and how does that work? Well, so basically the major difference between the ultra pure microbeads and our regular CD4 microbeads is that our ultra pure microbeads has been titrated in such a concentration, in such kind of a way that the beads is designed for massive, kind of messy samples. So what we are talking about a messy sample is that, sometimes when people are doing the liquid biopsy banking system, what they do is that they do collect the PBMCs, and at the end of the day, they do froze it, and then they store them at a liquid nitrogen. And when they need to have a study cohort to do the study, they saw them out, and then they do the stem cell, for example, extraction from the PBMC sample. And the major issue for that is that depending on the storage solution, depending on the whole technique, and depends on the sample quality and also how long the sample has been stored over there. Also, the sawing kind of protocol and how fast that has been done. Sometimes the sample will be quite messy. We are talking about the cell's viability won't be as great. And most importantly, there might be quite some small debris within those PBMC samples that got sorted out and ready for analysis. This would be specifically the case if we are talking about the cold blood samples, because typically speaking, they have been stored at a frozen condition for a much longer time. And the sample quality for them will, generally speaking, be poor than the regular fresh cold blood that got collected. So as a result of that, the CD34 ultra pure beads, in terms of, like I mentioned in the slide, in terms of its CD34 percentage among the total PBMC gating checked by flow, the purity is about very similar. But the major advantage for the ultra pure beads is that if we check out all the total force scatter and side scatter gating on the flow cytometry result, we can see that aside from the PBMC, at the debris section, when we are using the ultra pure beads to do the extraction, there are significantly less debris in it. So if you are talking about trying to get the best and the cleanest hematopoietic stem cells ready for your expansion downstream, and you don't want any small debris to have this potential impact on your downstream application, then ultra pure beads should definitely be the one for you to consider. And in general, I would say that it would be great to always think about to use ultra pure beads, because it's going to remove the debris and it's going to improve your sample quality. And price-wise, they are actually quite similar in terms of the regular standard vial size. So my 2 cents is that if it's possible, always try to start with ultra pure beads. And even if not, try to do a side-by-side comparison and see which one would be potentially for your preference.
Okay, all right, that's a good answer. Let's see, the next one says, my lab performs HSC CFU assays frequently, but we do not perform flow cytometric analyses. Would it be difficult to implement the StemMax HSC CFU assay kit, or should I continue performing the traditional assay with a microscope?
Well, like I tried to explain in the slide, and my 2 cents, of course, is you should definitely consider about switching. And the major reason, again, for that is, ultimately speaking, an imaging measurement based on morphology, the result could be improved by the experience of the technician, we will never be able to get rid of that certain degree of subjectivity within it, especially if you are measuring that by using basically a visual kind of measurements over there. But in terms of this kind of situations, especially if the lab has not previously having a flow cytometry experience, then I would say definitely to start with, you will need some guidance or support over there. If you do have a max quant flow cytometer, that would be fairly simple. You will likely get direct contact with our field application scientist, and he or she would be more than happy to simply arrange a time to help you on site to get training on how to run the CFU assays by using the max quant. But even if you don't, a good news is that our kit does support other flow cytometers as well. So if let's say you are using a flow crop facility as your cytometer resources, you are interested in measuring this thing, to bring in this kind of objective measurements, to potentially increase your measurement of both accuracy as well as efficiency, then I guess again another good way to do that is first to get in touch with us, have a talk with your local technical sales consultant, and potentially he or she would be able to introduce you to the field application scientist as well. And depending on the flow cytometer that is within your flow core, we can set up like the best way to guide you through on the protocol. Maybe sometime, if it's actually the technician that is using the machine, or you would be able to have the hands-on experience to use the cytometer by yourself directly. There'll be all different kind of situation. But overall, as long as you get accessibility to a flow cytometer, I'd strongly recommend you to at least give a try on this assay kit and see how that performs.
Okay. And it looks like we have one more question. It says, do you need to do a PBMC isolation first before a CD34 isolation from blood, or is there any way around this?
Yeah, that's a really great question. So we do have straight from beads that would be able to remove, to get directly target cells from the blood for certain type of populations. But we don't have one for the measurement of CD34 yet. So to answer this question in short, if you are talking about the whole blood or cord blood, you would still need to get the PBMC. I think at least at this moment, you still need to get the PBMC sample first in order to do a decent HSC separation. I think the major reason for that, again, is because the HSC percentage in the regular whole blood is extremely low. So even with our powerful column-based magnetic separation, another thing is that hematopoietic stem cell is a stem cell that will need potential downstream expansion. So having too much beads on them would potentially not be great for their downstream application. So with all those factors considered in, I think that is why we're still not really having a direct from whole blood to CD44 samples. But that being said, like I mentioned in the slides over here, we do have this custom system that can get you very efficiently from either whole blood or leukopak a very high quality PBMC sample or mononuclear cell sample separation samples out with a very clear high viability and also very low percentage of granulocytes and RBCs out from it. So you would be able to be very efficiently getting a large amount of mononuclear cells out for your downstream CD34 separation. So again, like I mentioned, a very good thing compared to the traditional FICO buffer is that our magnetic-based system is untouched mononuclear cell separation that will be able to reduce the granulocytes from 5% of the typical FICO yield to something less than 0.5%. And that would be a huge impact if you are doing downstream HSC separation, because there are consistent concerns in HSC research that when you are doing a separation, especially when the sample is put in room temperature for significant amount of time, the granulocytes or specifically neutrophils within the sample is going to have a potential impact on the hematopoietic stem cells. So that is why if you are doing, whole blood, cord blood, I would strongly recommend you to give a try on our custom kits. Again, shoot an email to your local technical sales consultant, and he or she will be more than happy to help you to do a quick demo. And another special shout out is that if you are doing a leukopak, I would definitely suggest you to try our leukopak-based custom separation for PBMC as well, because with the right tool and right instrument and the right platform, we're talking about would be able to help you to finish a mononuclear cell separation for a single leukopak, which typically you will need at least 2 to 4 people in a lab for about 6 hours-ish. But by using our custom kits and the right tool, we can reduce that time to a single person, and likely within 1 hour, you will be able to finish the whole mononuclear cell separation from a leukopak. So again, if you got any kind of blood resources and you want to do a PBMC separation from it, definitely shoot out an email to us, and we will be able to get back to you and introducing you the best kind of method to do it and the downstream ready for hematopoietic stem cell separations.
Wow, thank you, Richard. You convinced me with the 6 hours to 1 hours, and I don't even work in the lab.
That's a killer. Yeah.
Well, thank you, Richard. So that was our last question. Do you have any final comments for our audience?
I would say, like typically the best way really for you after today is if you have any question or any thoughts, if you want to give a try, really just shoot out an email with us. If you know your technical sales consultant, that would be great. Simply shoot an email directly. But if you don't, I think the best way to reach out us is by directly sending to our Max email. So that's macs@miltenyi.com. You will be able to simply send that with your question and where you came from, and then the technical sales consultant will get back to you. Like I said, there are many complicated projects in hematopoietic stem cell researches, and the best way is always actually talk with us. We all have been trained with a really good expertise backgrounds, and we have this knowledge, and we are always really willing to talk with you. So yeah, got any question, any thought, just reach out, and you will never be regret for that.
Thank you again, Richard, for your time today in discussing Miltenyi Biotec's complete workflow for HSC research. We would also like to thank LabRoots and our sponsor, Miltenyi Biotec, for underwriting today's educational webcast. Before we go, I'd like to thank the audience for joining us today and for their interesting questions. Thank you so much. Questions that we did not have time to go through today, or if you submit questions during the on-demand period, we'll be addressing by the speaker via the contact information you provided at the time of registration. This webcast can be viewed on demand. LabRoots will alert you via email when it's available for replay, and we encourage you to share that email with your colleagues who may have missed today's live event. So thanks again, Richard. Until next time, goodbye.
Take care. Bye, guys.